Hello, thank you for checking out A1 Math, and today we're looking at modeling exponential growth and decay within a word problem. Let's take a look at this first example. Okay, so the value of the boat is depreciated at a rate of 7% per year. In 2004, the boat was worth $192,000. They want us to find the value of the boat in 2013. So let's say you buy a big boat, it's real nice, but it depreciates. And they want to know by 2013 what would the value be in case they want to sell it. So what we want to do is we want to use the exponential functions. And since this is a decay, we're going to use the decay function. So right here, I know it's decay because it's depreciating. So I'm going to use my y is equal to a times 1 minus r raised to the t, with a being my original amount, r being my rate, and my t being the time, how many years I'm going to depreciate. So now I'm going to plug in my values here. So I have y is equal to a, which is my original amount right here, 192,000. So 192,000. Okay, and I'm going to multiply that times 1, which is always in the function, minus the rate. And the rate is 7%. So to do 7%, I'm going to take the 7% and move the decimal 2 places right here. So I have 0.07%. So that's the rate, 0.07%. Or 0.07 without the percent now. Now I'm going to raise it to t, and t is the number of years. Well, how many years would it depreciate? Well, you can get that by doing 2013 minus 2004. And that's going to get you 9 years. So I'm going to take that and raise this to the 9th year. So now I have my function of decay here. And what I want to do is go ahead and type this right into the calculator and hit enter. And when I do, I get $99,918.93. All right, so now that we have that, I want to answer this question at the bottom. Like, after how many years is the boat worth? Okay, what's it depreciated to, or what's it now gained in the case of growth? So after 9 years, the boat is worth about $999,918.93. Now it asks about the y-intercept. So what's the y-intercept? The y-intercept is going to be when your x is 0, what is your y? So when my x is 0, if I plug in 0 for x, then this becomes 1, and what's left over is this 192,000. And what does it represent? What is it? Well, it's the original value of the boat in 2004. Okay, so that's what the y-intercept represents. Okay, now what we want to do is graph it. So in order to graph, what you want to do is you want to plug in these values for x and then plot them. And you can plug them right in. So instead of plugging in 9, we're going to plug in 0, 4, 8, and 12. And they're going to get us our separate little values here. So when I plug in 0, then 4, then 8, and then 12, what do I get? At 0, I get that original amount here, $192,000. All right. At 4, I get $143,626. At 8, I get $107,440. And at 12, I get $80,000 370. And you would get that by just typing this into your calculator instead of using 9, using these numbers here. All right. Now, finally, I'm going to go ahead and graph it. So at 0, I go up to 192,000. About right here. At 4, I'm at 143, somewhere in here. At 8, I'm at 107. And at 12, right about here. Okay, so I can show my exponential curve and showing decay of the actual boat. Okay, and you can map that out. Okay, so that's exponential decay there. Growth is the same way. You just got to pay attention to what the word problem says, and if it's says something about decreasing or depreciation, then you use decay. And if it's growth or anything that increases, then you're going to use plus instead of minus and use the growth function. But that's exponential growth and decay within a word problem. I want to thank you for checking out A1 Math. Have a nice day.